a grand journey into the heart of Jupiter. Everyone knows Jupiter stands as the mightiest planet in our solar system, surpassing all the others by a staggering margin. It's an awe-inspiring giant, approximately 318 times the mass of Earth, and nearly 2.5 times larger than every other planet combined. From an early age, we learn that Jupiter is composed of swirling gases, and that it dwarfs our planet many times over. But for ages, scientists could only speculate about what truly lies hidden beneath those roiling cloud layers. Now, new findings have begun to reveal the extraordinary secrets within Jupiter's colossal interior. Along the way, astronomers have also explored whether Jupiter's mere presence has served as a protective guardian, shielding Earth from cataclysmic impacts that might have threatened all life. Our story begins about 4.6 billion years ago, when our solar system emerged from an immense disk of dust and gas. The gas giants, Neptune, Uranus, Saturn, and Jupiter, were the first to form. Jupiter, taking shape at roughly the same time as these others, gathered vast quantities of matter through its enormous gravitational pull before the inner planets had a chance to develop. From the start, Jupiter was destined to be the largest world in this cosmic family, made primarily of hydrogen and helium, about 90% hydrogen and close to 10% helium. It shares a composition remarkably similar to our Sun, which is about 70% hydrogen and 28% helium. Some astronomers have referred to Jupiter as a failed star, yet it possesses only 1,000th the Sun's mass, nowhere near hefty enough to initiate nuclear fusion. What the unaided eye sees when looking at Jupiter are its glorious ribbons of colourful storms, layers that appear to rest on what might be mistaken for a solid surface. This visible layer, called the troposphere, is about 31 miles thick, mainly composed of ammonia, ammonium hydrosulfide, and water. These substances give rise to Jupiter's distinctive red and white bands. Perhaps surprisingly, Jupiter lacks any actual surface. It's an immense swirling domain of gases and liquids, meaning a spacecraft sent there would find nothing to land upon. Yet, that doesn't imply a vessel would simply drift through the atmosphere and emerge out the far side intact. The intense pressures and scorching temperatures deep inside Jupiter would crush, melt, or vaporize almost anything that dared to descend too far. Human curiosity, however, is boundless, so we've dispatched spacecraft to orbit and explore this staggering planet. One of the most noteworthy probes is NASA's billion-dollar Juno mission, launched on August 5, 2011, becoming the furthest solar-powered probe ever. It reached Jupiter's orbit on July 4, 2016. Since then, Juno has sent back astonishing findings, reshaping our understanding of Jupiter in ways no prior mission had managed. For instance, data from Juno shows that the planet's swirling atmospheric stripes reach nearly 18 miles deep, holding an immense volume of gas, 3 times Earth's mass. Wind belts blow at about 223 miles per hour, and further research reveals that Jupiter's atmosphere spins at varying rates. Zones and bands might differ by nearly 328 feet per second in rotational speed. One of the spectacular details, the lighter bands zip along in the same direction as Jupiter's rotation, circling faster than the planet spins, while the darker bands move more sluggishly in the opposite direction, taking extra time to complete a full loop around. That said, how does this giant ball of gas and swirling storms remain cohesive enough to be recognized as a single planet? The answer lies within Jupiter's enormous magnetosphere, a vast protective bubble created by the planet's potent magnetic field, which can extend anywhere between 600,000 and 2 million miles from Jupiter, tapering into a tadpole tail, trailing millions of miles behind it. This magnetic field, generated by electrical currents in a layer of liquid metallic hydrogen within the outer core, is up to 20,000 times stronger than Earth's own field. Rotating in tandem with Jupiter, It sweeps up charged particles and accelerates them to incredible speeds, creating storms so powerful they can be detected by amateur radio operators here on Earth. The planet's magnetosphere is the biggest and strongest in the entire solar system, unleashing harsh radiation that strikes Jupiter's inner moons and would annihilate any hardware that ventured too near without protection. Speaking of moons, Jupiter is said to have 67 named and confirmed natural satellites, including Ganymede, the largest moon in our solar system, where an FM signal was recently detected. Whether that radio signal is scientific curiosity or just a fleeting cosmic phenomenon remains to be clarified, but it underscores how Jupiter's intricate system of moons can yield additional mysteries. An obvious question arises: does Jupiter contain a solid inner core deep beneath its gaseous and liquid realms? While certain findings suggest that the planet's interior behaves almost as if it were a rigid solid, despite being fluid overall, the definitive state of Jupiter's core remains unverified. If there is a genuine solid core, it's likely buried under monstrous pressures, measured at around 100,000 times Earth's surface pressure. Juno is ideally suited to refining our knowledge of Jupiter's interior composition, potentially uncovering whether a rocky or metallic center truly exists. Amid all the remarkable features, the Great Red Spot might be Jupiter's most famous. Observed since at least 1831, it is an enormous storm about the diameter of Earth, its mighty winds swirling around a high-pressure system between two jet streams. Dubbed an anticyclone, it rotates in the reverse direction of our planet's hurricanes and boasts wind speeds up to an extraordinary 400 miles per hour, compared with Earth's fastest recorded wind of 231 mph. Yet scientists have discovered that this iconic storm has been shrinking for almost 2 centuries, leading to speculation that it might vanish entirely within a few decades. During a July 2017 close pass, Juno soared a mere 5,600 miles above the storm tops, capturing images that highlighted the red spot's vibrant, churning details. Venturing deeper into Jupiter's interior, atmospheric pressure and temperature spike drastically, compressing hydrogen gas into an expansive liquid ocean of hydrogen, making it arguably the largest ocean in the solar system. Juno also uncovered enormous cyclones at both Jupiter's poles. At the North Pole, there's a mammoth persistent cyclone encircled by smaller ones, each 25-29 miles across. The South Pole exhibits a strikingly similar pattern, a colossal central storm about the size of the continental United States, with 5 additional cyclones arranged in an almost geometrical ring. NASA's Galileo spacecraft, which once orbited Jupiter, famously flew through one such hotspot during its mission, ultimately meeting its end in 2003, when NASA directed it into Jupiter's depths to safeguard Europa from contamination, a moon believed to harbor an underground ocean where life might exist. This leads to another reason we may owe gratitude to Jupiter. Many scientists suspect it acts like a cosmic shield for Earth. Because of Jupiter's massive gravitational influence, comets and asteroids can be pulled off their original paths, occasionally crashing into Jupiter instead of us. Before the 1990s, the idea of a large comet smashing into Earth seemed remote to many. Then came Comet Shoemaker-Levy 9. Discovered in March 1993 by Carolyn and Eugene Shoemaker and David Levy, it fragmented into over 20 pieces due to tidal forces from Jupiter's gravity. In July 1994, these fragments slammed into Jupiter's atmosphere with an explosive force of some 300 million atomic bombs. Dark scars, each measuring around 12 to 19 miles across, appeared on Jupiter's clouds, and localized atmospheric heating shot up to between 53,000 and 71,000 degrees Fahrenheit. Had such a cosmic visitor crashed into Earth, civilization-changing devastation would have followed. This dramatic event spurred a wider appreciation of planetary defense efforts and reminded everyone of Jupiter's vital role as a protective giant. In August of a more recent year, an amateur astronomer documented yet another collision, this time an asteroid barreling into Jupiter's upper atmosphere, producing a brilliant white flash. While these impacts remain relatively rare, the overarching point is that Jupiter's gravity well sweeps up loose debris that might otherwise wander into Earth's orbit. In that sense, Jupiter is often seen as Earth's big brother in the cosmic family, helping keep us safe from wandering threats. We continue to gather extraordinary views of Jupiter thanks to missions such as Juno, which has only completed about 1/3 of its planned mapping. There's reason to suspect Jupiter may indeed contain a rocky core enclosed within a layer of metallic hydrogen, but conclusive proof requires more data. Meanwhile, advanced imaging methods let researchers piece together dazzling, high-resolution pictures of Jupiter. Known as lucky imaging, this technique merges the clearest moments from video frames to capture extraordinary detail of the planet's swirling patterns. In thermal infrared photographs, we see bright spots of rising heat where thick clouds are sparse, while darker regions denote cloud layers that trap heat within. These revelations confirm that Jupiter's interior remains extremely hot, retaining energy from its formation billions of years ago. Viewed in visible light, however, Hubble's perspective shows the planet's reflective cloud tops, highlighting the swirling belts and storms from another angle. Even more findings likely lie ahead, with Juno continuing to orbit and observe. As it sends home data from each close pass, we approach a new chapter in understanding Jupiter's complex puzzle. Its possible rocky center, hidden under crushing pressures and immersed in a metallic hydrogen sea, and the dynamic atmospheric layers that craft some of the most mesmerizing sights in the solar system. So, if you're as captivated as scientists are, stay tuned. Further spectacular images and discoveries about Jupiter's realm are on the horizon, bringing us ever closer to unraveling the mysteries of the biggest planet that calls our solar system home.